folks, so now that we've taken a look at what an equation of a line looks like, what the x value means, what the y value means, what the slope means, what the y-intercept means, what we're going to be doing is taking all of those different components together and making ourselves our own equation of a line. Now, to make the equation of a line, we need only two things. We need to know what the slope is, and we need to have at least one point that falls on our line. If you remember back on the example that we just went through, there are an infinite number of points on our line. These blue dots represent points that are on there, but really there's a whole bunch of points in between each dot as well. Wherever the line is, there's a point that's there as well. So the x and the y just tell us a point that's on the line. So given a slope of a line, and given a point on that line, we can quickly create the equation of a line using what's called the point-slope form of an equation. And I'll show you what that looks like in just a second. So given our slope, which is m, and given a point on that line, which we represent by the x value and the y value, just think of an ordered pair. We have the x value first, the y value second. Think of the alphabet song, x comes before y. We can create an equation with the form, here it is, y minus y1 is equal to m x minus x1. Now at this moment, if you're looking at your computer screen thinking, what on earth do all of those letters mean? Let me tell you. The m is just the same m that we have as our slope. M is just our slope, and we're given this in our equation. Or we're given this in the information that we have, and we're plugging it into our equation. The x1 is just the x value of the point that we're given. We need a point. x1 is just the x value of that point. And the y1 is just the y value of that point. So we have our slope, we have our point, so the x1 and the y1. But now we have another x and we have another y. Now what does that x and what does that y mean? Well, if you think back to the example that we just looked at, this example had an x in the equation and it had a y in that equation. And we said that x is just the x value we pick, and the y is the y value that corresponds with that x, so that point goes on our line. So that y and the x are important because they tell us where our y and our x fall. And that y and that x are the y and the x that we have in our equation right here. So that y and that x need to stay there. We don't touch them. So let's pull through this equation. Let's pull through this blue equation right here using an example. Sometimes it helps a lot to start working through an example, to start figuring out what does this equation actually mean? How do I use it? So find the equation of a line with a slope of 3 going through the point A, which is negative 1, 2. And we want to write our final answer in slope and y-intercept form. Okay. Before I start a question, what I always like to do is pull out the information that I'm given. And I always write it on the side of my sheet here. Through high school I did this, through university I did this. It's just a great process to get your mind sorting through the information that you need to use in what you're doing. So my slope is m, and the slope is 3. We're given that in our question right here. We're given ourselves a point. The x value is always the first one. The y value is always the second number that's in here. And remember, this is my x1 and this is my y1. It's the point that we're given, not the plain x, not the plain y. Remember, that's the x and the y that show up in our final answer. So x1 is equal to negative 1. And y1 is equal to 2. Our next step from here, always write the formula down. So we have y minus y1 is equal to m times x minus x1. once we have this information written down, the next step is just to plug in what we know. So we have y minus 2, y1 is equal to 2, is equal to, we know what our m is. M is 3. X minus, our x1 is a negative number. This minus sign goes with this one here. So our negative 1 we just put in brackets. Y minus 2 we can't simplify, so it's just y minus 2. We can drop our brackets at this point. Is equal to 3 times, well, if I'm subtracting a negative number, I'm really just adding it. So I have x plus 1. From here, what I want to do is multiply this 3 through both of the terms inside that bracket. Y minus 2 is equal to 3x plus 3. Not 3x plus 1, but 3x plus 3, because that 3 gets multiplied through the 1 as well. Now we have y minus 2 is equal to 3x plus 3. We're almost done. We want the final form to look like it's in slope and y-intercept form. And remember, that means that I want to keep my y on the left side, and I want to move everything else over to the right. Now the only other thing that's on the left side with my y is this minus 2. Well, to get rid of minus 2, I want to add 2 to both sides. If I do negative 2 plus 2, I have 0, so all I have left here is my y. So we get y is equal to 3x plus 3 plus 2. And this 3 plus 2 we can simplify to 5. Y is equal to 3x plus 5. We know this is in slope and y-intercept form because all of my terms other than my y are on my right side, and the number that's in front of my y is a 1. Remember, if all I have is just a y and there's nothing in front, it's understood to be a 1. So we're done example 1. Example 2 says, find the equation of a line with a slope of 4 through the point B, which is negative 5 and 3, and write our answer in standard form. So the beginning of our question is going to start the exact same way as example 1. It's just our final form will look a little bit different. So again, let's go through and pull out the information we know. So we need to know a slope, we need to know an x point, and we need to know a y point. Well, our slope is negative 4. The x value of the point that we're given is negative 5. And the y value of the point is 3. So we have all of that. Once we have all of those 3 pieces of information, we're just jumping to that formula. So we have y minus y1 is equal to m times x minus x1. Remember to keep your x's on the same side as the m. Your y's are what you have by themselves on the left side. So we have our equation. Let's plug in what we know. We have y minus 3 is equal to negative 4 times x minus, my x1 is a negative 5. Remember, keep that minus sign there. Y minus 3 is just y minus 3 is equal to negative 4 times x minus negative 5. If I'm subtracting a negative number, I'm really just adding it. And just like we had in that last example, since I'm multiplying this bracket right here by negative 4, both of these terms need to get multiplied by the negative 4. Negative 4 times x is just negative 4x. And negative 4 times positive 5, negative times a positive gives me a negative. 4 times 5 gives me 20. Now we want our final answer to be in standard form. And remember, standard form means that I want to move all of my terms off to my left-hand side. So, my y minus 3 stays the same as it is here. If I want to move this negative 4x over to the other side, what I'm doing is I'm adding 4x to both sides, or I just move it over and change the sign from negative to positive. So I have plus 4x. Negative 20 moves over, so it becomes positive 20. And that's equal to 0. So my first part's done, everything's on the left. The next thing I want to take a look at is I want to make sure that my x term